Hello everybody and welcome to the Creatrix YouTube channel. I welcome you all in a fresh session of analog electronics. And my dear friends, when I say we are going to learn analog electronics from the very basic, I mean it. We will be learning from the very basic level to the very advanced level along with a lots and lots of questions. So before we do that, let me first introduce myself for my friend who is meeting me for the first time. My dear friends, my name is Ankit Goyal. I got AIR1 twice in GATE in 2014 and 2018. I was awarded the President of India Gold Medal in the year 2013 when I graduated from IIT Indore. Till date, I have trained more than 1 lakh students in the online and the offline classes and presently working as a director at Unacademy for GATE department. But my dear friends, the reason behind this series is because of the huge demand of analog electronics and the belief that whenever you ask for anything, we are there to deliver. Yes, my dear friends, we are here for you. We are here delivering for you. And when we say it, we'll support you to the very fullest level. And this series will help you crack GATE with the top rank. It will enable EC student to get 12 out of 12 and 5 out of 5 for electrical students. So my dear friends, if you want to learn with us live, then you can join Unacademy using the code ANKITESE to get an immediate 10% discount. And not only, my dear friend, 10% discount, it also brings you under my guidance so that I can help you do something that I have done. I can at least take you near to this goal. Okay. So if you also dream the same thing, then join me in this journey on Unacademy subscription using the code ANKITESE. Now, my dear friend, if you like the content that I deliver, you can watch more of my free videos on this URL, tinyurl.com/AnkitESE. Here you will find all my videos arranged subject-wise, chapter-wise, and you will find great content for free. And you are definitely going to love it. You are definitely going to enjoy. It not only includes conceptual videos, but it also includes problem-solving sessions. So just visit this once and you will fall in love with this URL. Don't forget it. It is a lifeline for you. And if you love the content that we are delivering on YouTube, we have created the first ever video book for you guys, where you will find all the videos along with all the notes that we provide arranged subject wise, chapter wise. So now, my dear friends, your dreams are no longer dreams. They are becoming a reality because you are getting a top quality course, well arranged, well structured, and that too for free. So what can be better than that? What can be better than that? Nothing, my dear friends. So we have empowered the dreams of those who earlier used to think that only the person with a huge amount of money can crack GATE with a top rank. No, my dear friends, that is not the case. Even you can do. Even you can do it. But yes, just you need to believe in yourself and visit this link. But remember, this is a case sensitive link, so write this in uppercase. Other than that, if you join plus subscription, you get all the top educators like me teaching you live in daily lectures, along with providing you daily practice paper, weekly quiz, test series, previous year question, practice question, crash course, rank improvement batch, and most importantly, clearing your each and every doubt. So if you join plus subscription, it is an entire world inside it. So you don't have to look outside. Once you enter plus, every need of yours will be taken care of, and we will make your journey as smooth as possible towards that destination of getting under 100, under 10 rank. Believe me, my friend, you leave that strategy part to us. You leave the content part to us. You just work hard and we will make sure that you obtain the top rank in GATE and ESE. And Iconic is a big brother of Plus. Yes, this is a little brother. So Iconic gives you everything that a Plus subscription gives, along with much more. The major part of Iconic is this personal coach, a person dedicated to you on a daily basis to get you the top rank, guiding you, getting your schedule design, making your strategy. Everything that you need to get the top rank is being done by this personal coach. He'll also create a study planner for you, which you can follow blindly and reach your destination with utmost ease. They will be analyzing your test result and tell you where you are lacking, how you can improve. So that way, my dear friend, everybody else will get a standard analysis, but you will get an analysis just tailor-made for you. Along with it, we have included study material additionally, theory and question bank, and soon we'll be introducing interview guidance into this. So this will become a complete package for a student who wants to take that journey from being an average student to sitting into a PSU or a MTech seat. So for them, this journey will be just like driving a Lamborghini to work. So that sort of a experience, that sort of a royal experience we are going to give you. So let's move on to the lecture, and if you want to join Unacademy, just make sure you use the code AnkitESE to get my guidance as well as to get 10% over and above whatever Unacademy offers you. So now let's move on to the lecture, dear friends, and let's see what we have in store for you.
Hi guys, in this video we'll be starting a new topic which is called as bipolar junction transistor, or in short it is called as BJT. Okay. Now it is one of the most important topics when we talk about analog electronics from gate point of view. It is your widest chapter, but if we are going to learn it from network point of view, if you are going to understand it from network point of view, then it is not very typical. So remove this misconception that it will be the toughest chapter for you, and let us try and work together to make it the easiest chapter. And how can we make it easiest chapter? Just by understanding it from a network point of view. Okay. So just like the case of diode, we'll be starting this chapter from the basics or from the construction point of view, and then I'll go into the circuitry where the BJT is used and how do we solve the circuits that are designed using BJT. Okay. So let us first start the introduction. Now, as you can see here, there are two terms with a transistor, or we need to understand three terms: bipolar, junction and transistor. So first of all, if I understand the term transistor, transistor basically means transfer of resistor. That is basically we are transferring resistance between the two terminals, and that is why it is called as transistor. In the naming, junction refers to a PN junction. Then in the naming we have the term bipolar. Bipolar means conduction by means of electron and holes. Okay, that is electrons and holes both are responsible for conduction. Now as you can see in the first figure, there are three terminals in a BJT. One is called as emitter, second one is called as base, third one is called as collector. Now if you understand the meaning of these three terms, emitter, it is called as emitter because it emits the charge carriers. They can be electron and or holes, but the region or the terminal responsible for producing the charge carrier is emitter. Similarly, collector, it collects the charge carriers coming from emitter. Okay. Then what about base? Base is the basic region from which the charge carriers flow while going from emitter to collector, and that is the working of this base region. So base is an intermediate region from which the charge carriers have to pass in order to go from one terminal to the other, and the region responsible for sending the charge carrier is emitter, and the region responsible for receiving the charge carrier is called as collector. Now here there are two possibilities: either emitter is P, base is N, collector is P, or emitter is N, base is P, collector is N. In both the cases, if you see, this is a PN junction, this is also a PN junction. So there are two PN junctions, one between emitter and base and the other between collector and base. That is why BJT is also called as bijunction transistor. What is meant by bijunction? It means it has two p-n junctions. Is it fine? Now as you can see, this is the IC view of the BJT. That is, if you purchase a BJT from the market, it will look something like what I have given here. There are three terminals in this device: emitter, base and collector. But these terminals, in the first figure that I have shown, one terminal is left, one is right and one is at the top. These terminals are not oriented like this. All the terminals are always on the one side of the device. Okay, so that is only a representation. The actual construction is not like this. Actually, all the terminals come on the same side of the device. Okay, so BJT has three terminals. Which are the three terminals? Emitter, base and collector. BJT is called as bipolar device because conduction is due to both electrons and holes, and there are two p-n junctions. That is why it is also called as bijunction transistor. Now if we talk about construction of the device, so while construction, first what I take is, first I take a substrate. Substrate means the basic wafer on which you are constructing a device. So I am taking the substrate as the p-type. This entire region is p-type. That forms the body of the BJT. Substrate implies initial material used for construction. Okay. Now what we do is, in some part of this substrate we do a doping in order to form N- collector. N- means, as I told you earlier also, lightly doped N region. Okay, so collector is lightly doped. Now we need to form base and emitter also. In order to form base, what we do is, we keep certain region in which the material is still p-type. Okay, that means this N- doping is done in entire region except this small box. This small box in which my cursor is showing, this has been kept p-type. Now what we do is, we form this N plus region. This N plus region is your emitter. This is for base and this is your collector. As you can see, there are two p-n junction, one p-n junction, other p-n junction. Similarly, we form a N plus region here also. This is collector only. I will tell you later on why we have taken this N plus. Now in order to bring out the terminals, we first deposit oxide. I told you that oxide acts as a insulating layer, so we have deposited oxide. Now we remove this oxide in certain region. Why we are removing oxide? We are removing oxide in order to deposit the metal to form terminals. Okay, so we will be forming terminals here like this. As I told, all the terminals are on the same side of the device: emitter, base and collector. Now why this N plus region? N plus has high doping. If it has high doping, you can say it has high charge carrier concentration, right? If it has high charge carrier concentration, conductivity is high and resistance is low. In order to reduce the resistance of the contact means this aluminium material. In order to reduce the resistance, we need to have high doping. So in some part of the collector, we have produced high doping and it will reduce the resistance. And by reducing resistance, we can reduce the voltage drop in the device. Otherwise, there will be large voltage drop across high resistance. Okay, so that is the basic construction of a BJT. Now, as I told, there are two possibilities in a BJT. When I have told you in the first slide, I told you about that. The first possibility is n plus p n minus. This is your ammeter, this is your base, and this is collector. Now, as I have told you, it is not necessary that the device is constructed like this. This is only the representation. What is the other possibility? The other possibility is if we interchange the P and the N regions, that is ammeter is P type, then base is N type, and collector is again P type. Ammeter, base, collector. Okay. Now, when we draw it in a circuit, then the representation is like this. This terminal is called as collector, ammeter, and base. Similarly here, base, collector, ammeter. Now you see the terminal with the arrow is called as ammeter. And what about the direction of arrow? The direction of arrow is always from P to N. So P to N means base to ammeter. Here P to N means ammeter to base. So see this arrow, ammeter to base, this arrow base to ammeter. So what is this arrow representing? It represents the direction of current, and the direction of current is taken from P to N. So it shows N, P, N. And current will go from P, P, N, P. So that is how we identify whether the transistor is NPN or PNP. You have to check the direction of arrow. There are two type of transistor, but mostly NPN is preferred. Why NPN is preferred? Because electrons mostly conduct. See, here ammeter is N type, so ammeter will emit electron. Here ammeter is P type, so it will emit holes. If electrons mostly conduct, and we know mobility of electron is more than mobility of hole, so that means more current. In NPN type of transistor, the mobility is high, and we know current is directly proportional to mobility. So that is why NPN transistor is more preferable as compared to PNP transistor. And similarly, when we talk about other transistors like JFET, MOSFET, you have to remember that electron conduction is always preferred over hole conduction because electron mobility is higher. Okay. Now let us understand what kind of doping do we perform in case of BJT. Now if you see here, suppose it is P and P. Due to P, we have shown it to be positive. Due to N, we have shown it to be negative. Due to P, again we have shown it to be positive. Okay. Now if you see here, NE, this height is maximum among NB and NC. So this height is more than NB. And again this height is more than NC. So the doping is something like this, that doping in ammeter is more than base, which is more than collector. Always remember, ammeter has the maximum doping density. This point is very important. Ammeter has maximum doping density. So generally the doping in ammeter is more than 10 to the power 18. Ammeter doping density is greater than 10 to the power 18. Now the question that comes to mind is why it has maximum doping density. Because it is source of charge carriers. It is the source of all charge carriers that are flowing in the device, and since ammeter has to produce the charge carriers, its doping has to be maximum. The second thing is that base is moderately doped. Moderately means it is intermediate between ammeter and collector. Neither it is heavy doping nor it is light doping. But remember, thickness of base is minimum. Now the question comes, why is the thickness minimum? See, if we go back to the previous slide, what I told is, here ammeter will emit the electrons and then electrons will go into the collector. But electrons have to pass through this base. Base is p-type, so it has holes. Okay. So if electrons are entering a p region, which already has holes, understand my point, here electrons are traveling from ammeter to base and base has holes. So these electrons will combine with the holes, right? Electrons and holes will combine and annihilate both electron and hole. They will combine. So what I want is maximum number of electrons should be able to reach the collector, and for that base must be thin. If base is thick, large number of electrons will combine with the holes and a small fraction of electrons will be able to reach the collector. We don't want that to happen. We want majority of electrons to reach from ammeter to collector. So base must be thin. And why is base thin? To minimize recombination. Okay. We don't want recombination to happen between electron and hole. Now the thing is, collector is lightly doped. So the first question that comes to mind is, why is collector lightly doped? So later on I will tell you that when we operate the device in active region, which we are going to do in this chapter, in active region, then what do we do is, we bias ammeter base junction forward and collector base junction reverse. Now in reverse region there is a risk of breakdown. In diode topic I told you that there are two possibilities of breakdown or two mechanism. One is Zener breakdown and other is avalanche breakdown. Now since there is light doping, which breakdown will occur? Avalanche breakdown. We know Zener breakdown occurs in highly doped region, and avalanche breakdown always occurs at higher voltage. So what I can say is, by light doping we can achieve higher breakdown voltage. So I just want to achieve a higher breakdown voltage so that breakdown does not occur in the collector base junction. Higher breakdown voltage means breakdown will occur but at a higher voltage. So in normal condition there will be no breakdown. For that we need to use light doping. Okay. But as I told you, a small region, there is a small region in collector which is heavily doped to reduce resistance. Okay. So most of the collector is lightly doped, but in the first slide or the second slide I told you, there is a small region which is highly doped in order to reduce the resistance. Then collector has maximum area. Collector has maximum area. Now why is that? This happens because CB junction is reverse bias. In reverse bias, there will be power loss which is equal to VCB IC. This power loss is high. So this power loss is occurring across collector base junction. In order to radiate the heat produced, we need to have large area. Because if large area is exposed to atmosphere, the heat generated within the device can easily be radiated to the atmosphere, and hence collector junction has the highest area. So these features about the doping of the BJT, you need to remember that emitter is highly doped. Why? It is the source of charge carrier. BJT is moderately doped and thin because we want less recombination. Collector is lightly doped and area is highest. Light doping to increase breakdown voltage, highest area to dissipate the power or the heat generated. Now if we talk about operating modes of a BJT. Now suppose we have a BJT which is like this, P plus and P minus. Now as I told you, there are two diodes. One diode is between emitter and base and other is between collector and base. This is collector, base, emitter. So we say that a BJT has two junction. One is the emitter base junction and other is the collector base junction. So there are two junctions, emitter base and collector base. Now every PN diode can be forward biased or reverse biased. So let me take the cases: forward bias, reverse bias, forward bias, forward bias, reverse bias, reverse bias, reverse bias, forward bias. Okay, so there can be four possible combination. Now different modes are arising because of this: forward bias, reverse bias, that is called as active mode. This is most important from analog point of view. Forward and forward, this is called as saturation mode. Reverse and reverse, this is called as cutoff mode. Reverse and forward is called as inverse active. Okay, it is not used because in inverse active what happens is we exchange the role of collector and emitter. That is, in this type of mode we are making collector behave like a source of charge carrier and emitter behaving like collecting the charge carrier. We are exchanging the role of emitter and collector, and I told you collector is intentionally low doping. Collector has low doping in order to increase the breakdown voltage. But if emitter is behaving as collector, then emitter has high doping. Due to high doping, the breakdown voltage will be low. If breakdown voltage will be low, the junction will easily break down. Collector is lightly doped in order to avoid breakdown, but emitter is heavily doped. So if you reverse bias emitter base junction, it will easily break down. So this mode will never be used. We will only talk about three modes: active, saturation and cutoff. Similarly, these four modes can also be represented on a graph based on four quadrants. Okay, positive axis means forward biasing, negative axis means reverse biasing. Okay, both are forward in the first quadrant, that means saturation. Emitter base is forward, collector base is reverse. Active, Both are reverse. Cut off. Emitter base is reverse, collector base is forward. Inverse active. Okay. So that is how I can show these operating modes in form of 4 quadrants. That is how you can understand. So this is very important when I talk about numerical point of view. You have to remember the 4 modes of the transistor. Sometimes this is also directly asked in ESE examination. The state of the junction in different operating mode. Now let us understand how does a transistor work. So I will first draw a transistor. When I am drawing a transistor, I am taking a PNP type of transistor. First region is P plus, the second one is narrow N, and the third one is widest. As I have told you, we will forward bias the ammeter base junction. In order to forward bias, positive terminal should be connected to P and negative should be connected to N. So this is written as VEE. If you see, positive terminal is connected to P, negative terminal is connected to N. And we will reverse bias the collector base junction. This is ammeter base junction, this is collector base. For reverse biasing, we use positive supply at the N and negative supply at the P. This is called as VCC RC, or let me write it as RE. Now the question comes, how does this device work? So if you see this, the ammeter base junction is forward bias. This junction is reverse bias. Now due to forward biasing, majority carrier holes will enter from P to N and it will be written as a current IE1. So what is this IE1? IE1 is hole current from ammeter to base due to forward bias. Okay, it is due to forward bias. Is it fine? So we get IE1. Now when this current IE1 is flowing, that is holes are entering from P to N, then definitely there will be some electrons going from, I mean to say holes are going like this. So electrons must be going from N to P. This current here is written as IB2 and when it enters ammeter it is called as IE2. So IE2 is equal to actually IB2. It is electron current from base to ammeter due to forward bias. Are you getting my point? Whenever a junction is forward bias, holes are flowing from P to N and electrons are flowing from N to P. And those two currents are written as IE1 and IE2. 1 minute, let me make a small correction. If electrons are going from N to P, current will go from P to N. So if I apply KCL here, I can say that this IE current is actually equal to IE1 plus IE2. Now IE1 is due to holes and IE2 is due to electron. Now P region is heavily doped whereas N region is moderately doped, which means electron concentration is less than hole concentration. So we say that IE2 is much less than IE1. Are you getting my point? Holes will be large in number as compared to electron because P region is heavily doped. Now see, this region is N and holes are coming from P to N. In N region there will be electrons. These electrons will recombine with the holes. Okay. these electrons will recombine with the hole and some of the holes will be passing over to collector. So that is called as IC1. IC1 is equal to current due to holes crossing from base to collector. Okay, some holes will go from base to collector and that current is IC1. Now you might be wondering that this junction was reverse bias. If this junction was reverse bias, how can holes go from one region to the other? Now see my point. Holes go from emitter to base. In emitter, holes were majority carrier, but base is n-type, so holes will become minority carrier. And in diode, I clearly told you reverse bias allows flow of minority carriers. Is it fine? Due to reverse bias, minority carriers can flow but not majority carrier. And since holes now become minority carrier, as soon as holes enter the base region, they become minority carrier. So they can cross over to the collector because collector base junction is reverse. Now as I told you, some holes recombine with the electrons, that is why IC1 is less than IE1. Entire holes are not crossing to the collector but only some holes. Now whatever holes have combined with the electrons in base region will reduce. Suppose there were 100 holes. Out of that 10 holes combine with the electron. Remaining 90 holes will enter the collector. Okay. If 100 holes were coming, 10 holes will combine with the electron and 90 will enter the collector. In that case, the 10 holes that combine with the electron will also terminate 10 electron, because electron and hole are combining, so electrons will also be removed, holes will also be removed. And for that, whatever electrons are lost will be supplied by the battery in the form of current IB1. Okay. So IB1, these are electrons supplied by the battery like this. If electrons are supplied by the battery, the current will be like this, IB1. Okay. So if I talk about the base current, if we talk about this base current, by KCL I can say this base current is IB1 plus IB2. Is it fine? Now if I want to distinguish between IB1 and IB2, IB1 is the electron current for those electrons which go from base to emitter due to forward biasing. What about IB1? IB1 is due to the electrons supplied by the battery to replenish or to resupply the electrons lost in recombination. Is it fine? Now there is one more current. As we have said that collector base junction is reverse bias, so there will be a reverse saturation current. Reverse saturation current will go from N to P. This current is called as ICBO. Now what is this ICBO? ICBO is reverse saturation current of collector base junction. And why it is O? CB is understood, collector to base. Why O? When emitter open. Means even if you don't connect any supply to the emitter, if this terminal is open, then also due to reverse biasing, a current will flow between collector and base, and that current is called as ICBO. So that means if we talk about collector current now, by KCL, I can say collector current is IC1 plus ICBO. This is due to holes coming from ammeter. This is the reverse saturation current. Similarly, we have written IB is IB1 plus IB2. This is due to forward biasing of ammeter base. This is due to electron from battery. Similarly, I have told that ammeter current has two components, IE1 plus IE2. This is due to holes and this is due to electron. Okay. Now, in all these terms, if I talk about comparison, IC1 is much greater than ICBO always. Similarly, IB2 is much greater than IB1. Similarly, IE1 is much greater than IE2. Okay. These relations exist between these current. Now, sometimes this reverse saturation current, you will see it will not be called as ICBO. It is sometimes also called as ICO. Now, ICO is a different current actually. It is ICBO plus surface current. There is some surface current also flowing at the surface of BJT. If you add that, then it will be called as ICO. But in many books, you will see ICBO and ICO are used interchangeably. That means we are ignoring the surface current. Now, as I told you, ammeter base junction is nothing but a PN junction diode which is forward bias. In forward biasing, how can you write the current? The current of a forward bias diode is written as the saturation current, the voltage across the diode. The voltage across the diode is ammeter to base voltage by eta Vt minus 1. And as I told in diode, unless eta is given, you will take eta is equal to 1. And since IE2 is much smaller than IE1, ammeter current is approximately IE1. Okay. So what I'll say is ammeter current is now IES e to the power VEB. It is PNP. So voltage will be from ammeter to base. Similarly, we can say since IB1 is much greater than IB2, IB is IB1 and IC is IC1 plus ICBO. Is it fine? Now, as I told you, IC1 is less than IE1 because some holes are lost in the recombination. So we take the ratio of both the currents and we call it as alpha F. That is called as forward current gain. Okay, that is your forward current gain. 1 minute. This is actually a mistake. IB1 is much greater than IB2 because here IB1 is due to electron supplied by battery and IB2 is due to forward biasing. So this also we have to change. Actually, IB2 I took it as due to forward biasing and IB1 due to electron supplied by battery. Okay. Now when we talk about electrons supplied by battery, why they were supplied? Due to or to supply electron lost in recombination. Now understand one point of mine. Suppose 100 holes were coming from ammeter to base. Think like this. Suppose 100 holes are coming from ammeter to base. Some holes will recombine with the electrons. I say that 90 holes reach collector. So how many recombined? 10 holes recombined with the electrons. So 10 holes, if they recombined with electrons, they would have consumed 10 electrons. So these 10 electrons will be supplied by the battery. The electrons lost in the recombination will always be supplied by the battery. This current I am calling as IE1, this IB1, this IC1. So I can say IC1 is IE1 plus IB1. Due to this, we define another factor IC1 by IB1, which is called as beta F. It is also called as forward current gain, but alpha F is less than 1, whereas beta F is high, approximately 100. See like this, 90 holes are going into collector. So if you take collector upon ammeter, 90 upon 100, 0.9, less than 1. If you take collector upon base, 90 upon 10, that is 9, so it will be high. Practically it is of the order of 100, but here in this example I am taking it as 9. And then we know IC is IC1 plus ICBO, and IC1 is written as alpha F IE plus ICBO. So that way we can write down the collector current. And since this ICBO is reverse saturation current, it will always be a function of temperature, that is double for every 10 degree centigrade rise in temperature. Similarly, this IES is the saturation current. This will also double for every 10 degree centigrade rise in temperature. So let me summarize what we have learnt in this lecture. I have told you about construction of BJT. That is not very important to us. Then about the doping profile, that ammeter is highly doped, base is moderately doped, and collector is lightly doped. Then I have told you about that collector has maximum area in order to dissipate the heat generated, light doping to increase breakdown voltage, base is thin to minimize recombination. Then we have seen there are two type of transistor, PNP and NPN. I have told you about circuit symbol of both. This is NPN. This is PNP. Then I have told you about transistor action, in which I have told you that ammeter current is IES e to the power VEB by eta Vt minus 1. Then I have told you IC1 is alpha F IE, IC is IC1 plus ICBO. ICBO is the reverse saturation current of collector base junction. It doubles for every 10 degree centigrade rise in temperature. Also IC1 I told as beta F IB1. Okay, alpha F is less than 1, beta F is greater than 1. And I have told you how does a BJT operate. Okay, so this is the basic operating principle of BJT. From the next lecture onwards, we will see how BJT is connected in the circuit and some numerical aspects of BJT or the equations that you need to remember. But in this lecture, if you want to remember something, this is the first thing that you need to remember. That is the equation for ammeter current. It is same as that of a diode, because ammeter base junction is nothing but a PN diode. Okay, so we will continue in the next lecture. Thank you.
I hope all of you have enjoyed the lecture that we were providing and all of you learned something very good. Now is the time to learn about the Unacademy subscription. So as I told the benefits of the Plus subscription at the very beginning, let's go through them very quickly. Live classes you get by the top educators, crash course, rank improvement batch, doubt clearing, weekly quiz, test series, previous year question, practice question, everything in one subscription called as Unacademy Plus. And iconic is one level higher. It provides you a personal coach who will mentor you on a daily basis, who will guide you on a daily basis, along with providing you study planner, test analysis, study material, and soon enough interview guidance. So if you are looking to join Unacademy, let's see what are the pricing. So my dear friends, before we see the pricing, just see the link. This link will help you crack GATE and ESE with the top rank, because we have created the first ever video book for GATE and ESE for my YouTube family, and you will get the notes as well as the lectures here. Just make sure that you write this link in the uppercase and you will get to the first ever video book for GATE and ESE, and it is nothing but revolutionary. Now let's see the pricing of Plus subscription. So for 12 months the pricing is 3250, but if you apply the code Ankit ESE, it becomes 27225. For 18 months it will be 34650, and for 24 months 39600. Believe me my dear friend, this is the most affordable pricing, and the longer duration subscriptions are more cost effective as compared to shorter duration. Like here it will cost you 1650 per month. Okay, this will be 2000 per month approx. This will be around 2250 per month. Then if you go for iconic for 12 months, it is 5250. With code Ankit ESE it becomes 45225, and 2 year subscription becomes 66600. So the choice is yours, but take a longer duration subscription for more cost effective solution, and to give GATE and ESE at least 2 times, so that if you once crack GATE, in the next attempt you can even get ESE. And other than that my friends, you can download the Unacademy learning app right now, because there we provide live classes for free, test series and live quizzes for free. And once you download it, make sure that you follow this profile. This is my profile, so that whenever I come live you will get the notification. And this is the Telegram channel for our team. Here you will find all the lecture links, all the lecture files, and all the links for the special classes. Other than that my friend, my personal Telegram channel also you can join, t.me/gateair1. Here you can get in touch with me and we can take this journey together. Okay. Other than that, we have other YouTube channels like Mechanical, Civil and Telugu, JEE channel, Computer Science, Gate Question and Electrical Junction, Pathshala and GS Terminal. Electrical Junction contains short videos of great concepts. Pathshala provides you animated content. JEE preparation can be done through these 2 channels, Unacademy SSC JEE and GS Terminal. And you can refer the other channels to the other friends in respective branches, so that they can also be benefited. At last, I would like to say, please share, like and subscribe to this channel. Subscribe to this channel, and not only subscribe, press the bell icon so that you get notified whenever a new video comes. And share these videos among all your college group, among all your friends, so that we can create the first ever revolution of free education in field of GATE and ESE. Thank you to everybody for dedicating time to watching this video. Please move on to the next one as well, and take the benefit of all the free content that we are providing. And in case you have completed the series, do make sure you watch the other subjects available on this channel. Thank you.